thing you need to know about databases is that the primary data structure is a table. It has columns, rows, a title, and what you do with it is you write SQL queries in your application to retrieve data. And this table structure is the same on the server side as it is on the client side. So when you're querying a table on the server side, the same structure that you see on the server side is exactly what you're dealing with when you get it on the client, which is convenient. So this is the client stack, and the area in blue is the area I'm going to be focusing on. So, underneath my layer, you can think of things like the C driver layers that you would normally have to use. If you didn't have an abstraction on top of those, you'd have to use those directly, which would be really hard. You might have drivers that are built on sockets, and then I have other areas which I'll talk about at the end, like vibe and maybe standard event. So my design is a two-layer design. So I have essentially a driver layer and a front layer. So when I originally started this, I was just going to sit down and specify an interface for this, and then just go driver by driver and try and map what the particulars of that driver were for an interface. And one of the things I quickly realized when I got far enough into it is it's a lot of work to reproduce a lot of code. And so I just moved up the task of having a front layer so that I could save a lot of work and just separate a lot of concerns that are front-end concerns with things that are driver concerns. And I'll talk about that as we go. So the things on top of my layer I'm not really addressing, which are discussed in the previous talk, things like an ORM layer, utilities, query builder, that would be above the layer I'm discussing today. And you can either build applications directly on top of this database interface, or you can use it as a foundation for higher level services like ORM. So these are the types that I have in my interface presently. And they should be pretty familiar if you've worked with a database before. These are fairly standard objects that you would have seen in previous interfaces, so they should be familiar. Things like a database, a connection, a statement. The column set is for meta information about the table, things like what the column name is and its size, things like that. The row set is the actual data structure that holds the table that you get back from the database. And then on top of, below that row set are things which come out of that row set, such as the row and field. So what I want to show you now is what it actually looks like. So this is just the most basic example that I can come up with here. And what you can see is that I've got a standard database import here, standard database MySQL. And by the way, this work is targeting Phobos inclusion. And one of the things that's not entirely clear yet is how much of it belongs there, because there's pros and cons of having it in there. But for now, I'm acting as if maybe at least one driver can get in there, maybe a OWC driver, maybe a SQLite driver, and the reason is because those are already bindings in Phobos. So I think that there are some good choices for things that can get inclusion, and maybe some things that maybe don't belong there. But you simply import it, and you call this factory method called create database. It has a URL syntax where the protocol is specifying the name of the database, the server, the DB. So there is a URI mapping here that makes sense for how you would want to get to a database. From that, you have this chain style of calls where you can execute a query. You say .rows to get the actual rows of that query. And you can call write rows, which is just a nice utility method for actually displaying the table nicely on the console. The one thing to note here is that, unlike the previous slide, there's no types at all. So even though that these types are described here, you don't actually have to work with the types. You can follow from the examples and just use this fluent style in the interface in what's hopefully a natural style. So just to do a more classic style here, this is really a very similar example here with each of the objects from those types broken out a little bit more clearly, so you can actually see how it is you go from a database to a connection to a row set, And then in this case, I'm looping, I've got this nested loop here just to make it familiar for anybody who may not be proficient with ranges yet. This is what it looks like with just a classic for loop. The outer for loop is for looping through the rows. The inner for loop is for looping through the columns in each row that you get back in those rows. And then there's a field accessor in the middle there. And that's pretty straightforward, I think. You can improve upon that if you just want to have a more range-based style nested loop. You can use the column set. So when you get the column set, you can actually use that as an index to the row to get the field accessor. It's just a little bit cleaner. That's one way you can use that. So these types are reference types, and this is a really fundamental aspect of the design. I had looked at previous work that has been done, considered this a lot. I think my thinking in coming to this project was that the first thing I wanted to make sure of is that these had deterministic destruction. That was really important. So you don't get that with classes. You do get that with reference counted structs. So that's what these are. And so these are reference types if they're implemented with structs and ref counted. So I'll probably go into a little bit more detail about how that's affected the design. But one of the things that's clear here is I've got this method called getCustomers. Within it, I'm creating a database, and I'm getting query and rows, and what I'm missing actually here is a return statement. But you can imagine there's a return at the end there, and it's simply returning the row set. But this is completely fine because all of these objects are holding references to the parent object, so escaping out of this function is just fine. So everything is designed to work without worrying about what the lifetime of the struct is. They're all ref counted, and it's all taken care of it. So you can return things like this. Even this row set's going to hold on the database as long as that object exists. So that's what I mean by reference types. Okay, so I'm just going to go briefly through each of these types to give you a sense for what the interface looks like and some of the highlights. There's a lot more calls in each of these objects than I'm going to list here, but I just want to give you a sense for what each of these things' responsibility is. So a database is the top-level context object. The first thing you have to do, of course, is create database. You can create a database with a URL, which means it's the default URL for everything. So if you ask for a connection like you do in the third row, you will get the default URL. And that's just a convenience so that you can go, if you want to have, if you have a lot of places in your code where you want a connection, you're always connected to the same database, you shouldn't have to specify the URL multiple times. So that's what the default URL is about. Or you can specify a specific one for the connection. It also supports, rather than a URI, a named key, which is something which hooks into a resolver. This is a resolver that you can use. You can add yourself to specify that it should look up configuration. Because a URI isn't going to work for everyone. Some people need to hook into existing configurations. Some people would just want something simple where they will look up the configuration, the home directory, but it has that dual purpose. And in fact, you can query right on the database object. I'm going to talk more about that in a second. But this design is designed to make it as easy as possible to do what you want to do, rather than having to do it an exact particular way. I should mention here, one particular here is when you say connection, you're getting a connection, but if you're on the same thread, you're going to get the same connection back, and that's just that's something that you probably want. However, if you need to get multiple connections on your thread, then you call create connection. So you have the ability to do either. Also, the database is responsible for connection pulling, so if you are on different threads, it's going to pull them out of a connection pool. Just a little more detail on the connection string, which is the two methods you can do. You can specify a URI-based string, and this is something that is extendable to support a lot of different parameters that you might like, including ones that may be specific to your database. Or you can do this name source one where it looks up in a config file like that one right there. Okay, this is a connection object, And you get it from the database by saying, in the previous slide, database.connection. This first one, if you need to go back to the parent for some reason, like you're handed a connection in your code and you need to actually access the database, you can always go up in the design. So it's flexible in that regard. The rest of these calls have to do with transactions. I'm not going to talk about transactions a lot, but you obviously want to have good support for transactions in your database because they're important to many people. Okay, so this particular example here is an example of a transaction involving two different databases. And I think this is the only transaction slide I have on here. But what's happening here is that I'm getting a connection to two different servers. And what I'm going to do is I'm going to commit to both of those databases. First, I'm going to issue a query, and then I'm going to commit. What this is showing here, I think, is one of the ideal uses of scope. It may have even been one of the original ideas for why it was created, in the sense that what you're trying to do here is have clean code that's going to handle the state properly. In other words, if both of these queries succeed, then they're going to commit. If either one of them fail, you want to roll both back. So I really wanted to show the example of scope here just because I think it just directly ties to this idea of doing multiple transactions, which is really hard to do using try-catch. So it highlights a particular feature of D. Coincidentally, it just happens to be transferring 500,000 from one account to the other. That's coincidence. And that's an example of a transaction. This is a statement object. Its responsibility is to handle prepared queries and input binding. So a prepared query is one where you send a query to the server once, and then you repeatedly issue parameters over and over. So this is an optimization. What's happening here is that you're saving the cost of having to send the query repeatedly to the server where it gets parsed. Instead, you send it once to the server, and it has a context for that prepared query, and then you repeatedly issue this form of a query, which doesn't include the SQL, but just includes the parameters that are bound to that query. So the two question marks will correspond to the list of arguments here. So that's one of the important reasons why there's a statement object, is so that you have access to that capability. Statement also has some other accessors. Now, there is a statement.rows and there's a statement.results. And the reason why there's two of these is because a lot of people don't realize that many databases can return multiple result sets per query. The most common use case by far is that you simply want to issue a query and you want to get the results back for one query. But this is something that the API needs to accommodate because other client layers support it, and some people really want this capability. So if you just say .rows on all your queries, you always get back just one row. If you need to get access to multiple result sets, and you say .results, and you get a range over multiple result sets. And we'll get into the statement in a minute. So here's just at this point, I want to point out some flexibility in the interface. So there's 4 different ways here that I've issued a query. The first way is I've just taken a DB handle and or DB object, and I've just said db.query. So if I want to do the minimum amount of work to just get something done without having to set up other objects, I can do that. I can do a query on connection. I can do a query on the statement. And I can do, now this 4th one is actually missing the query call. I'm going straight after the rows. And I actually at first thought that should be an error because the user didn't call query. But then I thought, well, maybe it should just execute the query if it hasn't been executed. And I think we're going to see how this approach works out. So I think it's better to do something sensible rather than to just throw an error and say, hey, you did not call this in the right sequence. If it makes sense to just execute the query because you know you've asked the rows, then it should do that. Now, I'm going to try and map as many of these things as make sense across the objects. I don't know if it makes sense to, say, have a field object be able to execute a query. That would not probably be something that would be a good design, but there are a lot of functions that you might like to have the convenience of calling on any of these objects. Okay, so you get this row set back, and a row set is an input range. So this is a big deal because I think a lot of other libraries suffer from not having this abstraction. Usually other libraries have their own type of interface, things like next or get next row or is done, and it's very specific to that API. And D benefits from having a really good model for abstraction and iteration, not iteration, but ranges, which map perfectly to this type of resource. In fact, I think it's a limitation of iterators that it's actually hard to do this with iterators. I think I've tried to do that before, and it's just you run into problems, and ranges work really well for this kind of resource. So this is an input range. It also, at this level, gives you the row width, the columns. The length of the result is the number of rows, but you can't call that until you have all the rows, unless you have a special kind of result set, which is either you've either got all the rows, or you have a detached row set, or you've configured the driver to say, I always want to get all the rows, but I wanted to have the ability for you to get the length, which is the number of rows. And it's called length because I decided to reserve rows for actually getting the rows and columns for getting the columns. It's sometimes tricky to figure out what the right naming scheme is because there are some conflicting elements to doing that, but and it's fluid.
Can I ask a short question?
Yes.
Do you cache the, like, if you iterate or use the range of a result row, is all the data already there, or do you read it before everything arrived?
So by default, this is going to only be one row at a time. It's an input range. It's lazily fetched. By default, you would not want it to hold the entire result set, but you can certainly enable that really easily. There are a lot of ways that I can imagine that could be done. So it's flexible in that regard. So let's see, the row interface you can its purpose is to represent the row and provide field access. So you can get fields by index, you can get them by a string name. It should be case insensitive because most databases are. And you can index them by the actual column object as a convenience. And then you have at the bottom of this set of objects the field object, and this is where you actually get the values out of this row. And there's a whole bunch of things here. There's, of course, field to string. The next set of types should look familiar to something like convert. You can ask for a specific type as T and get whatever type that is. And this is where it will do conversions. So the information that comes back in the row set is typed. You can ask for it in a different type. It'll do the conversion if necessary. If you ask for the type that it's already bound to is that same type, it'll return that. So by default, it should handle what makes sense. Now, it may not. There are certain cases where it does not make sense, and those might throw. And in fact, there's another reason why this first set will throw. And the reason is because of nullability. So fields can be null in the database, and given this first set, the as set, if you try to query something that is no, it is going to throw. So that may be okay depending on your context, but there's another set of calls that you can use if you're expecting that and you want to have a nicer way of handling it. You can ask for a variant, which is standard variant. If you say field.get, you'll get a nullable T. Or if you can say field.option, which is option T. Now this option T is similar in concept to the C++ optional, which I guess nullable is actually filling that same role. But there was some discussion I followed in the forum about option being extended to support ranges, and that idea sounded really good to me, so I actually threw that in too. So maybe it looks like that thread is old, but it seemed like there was a lot of interest in it, and I think it's a good idea too.
Sorry, one question about the types. Here. Yeah. So how hard would it be if you don't have a native representation of the type in D to plug in your own type, let's say numeric with a precision, to plug it there, to not to throw, but to know how to convert from the database binary to to the type that you can use in D?
So I don't know if I thought about that specific case, but it makes sense in the sense that I think you should be able to extend get or as for a specific type that you're interested in. If you want to have it mapped in a particular way, that sounds like a good idea. Maybe a UCFS call that would extend this to support a particular type. Another question?
Is there a means for clients to inspect the types of the database? Like, let's suppose you're writing a program to go to an unknown database, scan its tables, and generate like a script to recreate the database somewhere else.
Yes, there is. I have a list at the end of this talk with a bunch of things that I need to do, but one of those items is support for schema metadata. So in principle, that would be part of a good API to just be able to discover in a platform-neutral way what are all the objects in the database that you can query.
Just one small comment for the user-defined conversion.
Sorry, I can't hear you. Could you speak up?
Just one small comment for the user-defined conversion. I can definitely see this this template taking a function that will then put out your conversion thing, but for that you would have to somehow export the types that you expect the database to give you back, and then do the custom conversion based on that.
Mm-hmm. So yeah, I think that would be a good idea, is to be able to extend through a function that you pass in to specify how the types are returned. I think I understand that. I think there's lots of ways to extend this. The main thing I'm trying to do is to cover what users are most expecting out of the interface. But it certainly can be extended. Field accessor, you can say field is null, field .name, field.type. Now these name and type are overlapping with the column structure, but just out of a convenience, if you're holding a field object, you may want to just have some metadata attributes for that come from the column type. Okay, so many cases you're querying the database for a single row. So you're just getting back a single row. You don't necessarily want to go through the trouble of looping over records when there's a single record. So for that, there's this into function. So you can say, if you know you're expecting a single result back, you do the query, and you say into, and this is a variadic argument here that just takes these variables by reference and sets them in the order of the columns that appear in the query. So it's just a much more compact form for doing a particular use case of query that is common. And it appropriately binds into these types. Question?
Yeah, how'd you do type checking on those variables?
It does conversion. So you don't have to match a type. If you, there's a possibility, I think, at throwing if you've got a type pair that are incompatible, but it's going to do the right thing.
Okay, thanks.
Okay, so on the row indexing part, I said before that you can say row.string or row opindex.string, row opindex.integer. Using a string is potentially a little slower, and using an index is a little bit faster. Now, many people won't care about this. They'll just go ahead and put strings in there and everybody will be happy. But there could be a performance issue with that, and using integers is not particularly friendly in an application. So one approach to that you could take is to use this MIXIN. and I'm just showing this as an example. I'm not saying this is the best approach, but it was one that did occur to me. You could use that to essentially do the code in the block where it inserts the code and puts them into integer variables so that you just have the convenience of being able to use these variable names instead of literals. Andre?
If you go one slide back, 2 slides, I have a question. 2, yeah. So you have a DB query into, but those are single variables and the query returns multiple rows. So I would expect there would be some sort of into for a given row, but not for entire query. How do you do it for, I want to select this row, the current row, into 4 variables, but not the whole query.
Hold that thought.
Okay.
This particular form is expecting 1 row in the result, and I haven't decided yet whether it should throw if there's multiple rows, or it should just pick off the first row. Potentially, if you've got this in your application and there's multiple rows, it could indicate that there's an error. So probably the case is that it should throw. So this is the MIXIN, and you can see here that in this loop, you can just reference the rows, the fields within the rows by a little bit more friendly names, but you have to probably put this index suffix on it because that way you can avoid conflicting with other variables. This is okay. Maybe people will like this, and this will be a good thing to have in the library. But here's another approach. Is I realized after I did the into, I thought the same thing that Andre asked and said, this seems like a good idea for an individual to do that. So in fact, the other one is on the statement object. The into is also defined for a row object. So you can, in fact, for any particular row, do this same type of into statement. Question?
Yeah, can you move to the previous slide? Wouldn't that make more sense to actually generate an enum rather than variables?
Yep. No, because it's runtime. I don't think the enums, well, maybe they would actually.
MIXIN is compiled
Yeah,
time.
you're right. I'm sorry, they don't have to be compiled time, do they?
Yeah, so.
Question?
So about that and about the folks that really don't care about performance, there is in Python there is I forgot its name. It's Psycop2 library. I don't know. I don't remember. But there is extension of it named tuple, where you can say user.name, right? Like a classic dynamic typing thing. And you know, reading Andrei's book, can we do the same thing with the? Is it op dispatch? I'm not a...
So I think this question was, how can I get what if I get a tuple out of this row? And I actually did think about that because I was getting, when I started to think about the possibilities of into and all the things that you could do with it, this is a little bit different because the into is taking a list of variables, but I'm also imagining at the same time that you could return a tuple. But in D, a tuple has certain compile time aspects to it. It is certainly possible to do, but let me actually talk about that when I get a little bit later in the talk, because there's some surprises there. Some other possibilities with into, it could take an output range, and it could take a struct. So this second line here is really a hook for serialization, potentially. So the idea here is this could be just an entry point for some other type of library, or even potentially a part of this one in simple cases where it'll do reflection into a struct automatically. You could tell it in some way how the struct should be populated, or it could just discover by looking at the fields and do a good mapping. So, but that is not the main focus of what I'm addressing here. There's 2 modes of this interface that I have. So what you've been seeing up to this point is called the direct interface, which is you are developing an application for a particular driver, MySQL, SQLite, Oracle, and that's all you're using in your application. And you're not planning on switching databases at runtime, and you want the maximum performance. So you want the direct interface in that case. There's a second interface called the poly interface, and this is a little bit like what you would find in other platforms. And in fact, I think it's a direct interface. It's something that's probably not something you would find in other languages. But you need this poly interface, I think, to be on par with other libraries. And what it does is it's an indirection layer on top of the drivers so that you can, you can choose which database you want to connect to at runtime. So if you have, there's actually two cases for this. One is you're designing your application and you don't later want to refactor your code to use a different interface, although that wouldn't potentially be hard because, again, it's a standards interface. You should just be able to change what you're importing to, and the rest should stay the same. Of course, you may have to change other things like your SQL statements, which may be a dialect that work differently in a different database. But the poly interface says you can establish connections for multiple databases and use them. You can, if your application either uses multiple databases or you want to be able to configure at runtime or within configuration which database you want to point to, that's what poly is for. This is the details about how you might register it. And this is, I think, a little bit unique because I think a lot of platforms, when you go to them and you want to use a certain database, this is true for Java, you've got to go on the internet and look for a jar. Or if you're in another language, you might have to look for a DLL. The details of getting support are usually done by bringing in some kind of library resource. And since this library is all template-based, you do not need to do any of that. There's no additional dependencies. What you do have to do here is you have to register the databases that you want to use. So just by doing this static call, this will add support for that in the poly interface. This is something that can be tucked away, away from what the user is. So this is not something you would see, whenever you're setting the database. It could be done statically in the application, and whatever databases you've included support for will be available when the user asks for this. Also, it might make sense to make the poly interface standard database. So if you're just starting out, you don't know what particular database you want to use, your default is that you get the poly interface. Handle accessors are just mainly a convenience. If you have a reason why you need to get to an underlying resource from the driver, for instance, MySQL has a MySQL pointer. If you need to do something particular, and this is maybe more of a convenience for development than anything else, because naturally the interface should cover you as far as whatever you're trying to do, but it does provide access to the underlying handles if you need them. You need to be careful though, because of lifetime issues. This is basically a pointer escaping from the reference counting, and if you do not, in this cert case, the reference count goes away and you're left with a pointer that's been destructed. So you have to be careful with that. Just a little word on the test suite. A library like this really has to put a lot of emphasis on how it's being tested because there are so many things that have to be checked for it to be considered usable as a library. So there is a test suite and it's templated. So the idea here is that you just give it the database object and instantiates the entire test framework for that. It has knowledge about which, what is supported within the driver. So drivers that may not support a particular feature it will not try and test that feature. But it is a common test framework for everything. And it does two things, actually. It runs the direct driver. It does two test passes, one for the direct driver, one for the poly driver, just to ensure that this driver also works for the poly driver. There's some care here to not let this get in the wild and have somebody run it and have it completely do something to their database. So there needs to be some protection for this test suite so that it's very sandboxed and really hard to run without in any way tampering the data, but I think there's just certain caveats with having a test framework and having it be released as part of the library that you need to be careful with that. So I want to talk about output binding. So output binding is a C-level feature of most database drivers, and all it is it's a buffering technique in which you are allocating buffers to hold row results, and you get access to that buffer while the query results are being returned, and you can access the buffer. That's a primary way that most clients deal with how you get data. So The nice thing is that the user's not exposed to this at all. This is all handled by the ROWSET internally. The ROWSET's a container, and it just handles it. It really does this conversion into a range. So you don't have to deal with that. What I want to talk about here is something called array output binding. So several drivers not only support the ability to provide you with a buffer for one row, but they allow you to specify an array of rows to be bound into. So this is an optimization. When you call to get the next row in the C interface, it may populate 1,000 of them at a time, and then you're handed back a buffer with 1,000 entries at a time. So the round tripping there is much less. So I've got a simple example here where I'm going to query, and this is without array binding. I just ran this. Of course, all of the testing I've been doing have been on my laptop, so I have databases running on virtual machines just so I can do this. It's 203 milliseconds with this 1,000-row table. It's not a big table, but it's just convenient to work with. Reasonably fast. I mean, not by any stretch world class. So let's add this modifier here, row array size. We'll just have, internally, we're telling the driver that I want to buffer 100 rows at a time. Okay, so this performance has now gone down to 32 milliseconds. So just by putting in this optimization, I get a fairly substantial improvement. So the thing here is that you really want to support this array binding. However, it gets better. So this is a 1,000-row table. Does it keep getting better if I add a higher number for the row array size? So let's raise it to 500. Now it's 2 milliseconds. So clearly, bigger is better here. It really helps to increase that. I don't know if in a real-world query there will be diminishing returns, but in this particular example, it's working out nicely. So it's a 1,000-row table, so maybe I should try just getting all 1,000 rows. So now it goes down to about 600 microseconds. So in just looking at this, I mean, I think I was surprised. I knew it really made a difference, but it really makes a huge difference here. It's about 2 million rows per second. It's a 400x improvement over the original case. And I threw in a graph there just because I wanted to see how it was responding to increasing buffer sizes. I had to put a logarithmic on the y scale to make the graph look reasonable. So this is a huge win. We definitely want to support array binding whenever possible. Some databases support this feature called skip parameters. And what this allows you to do when you're binding the results is it allows you to have the buffers populated in such a way that instead of having separate array bindings per column, it actually puts them all in one contiguous structure. I haven't timed this, but this could be an additional improvement depending on what you're doing, because now you have the entire row set in contiguous memory. So that's something I'd like to support as well. Another thing about row sets that we can do is we can detach them under certain conditions. So, and this is something that you don't get by default, but you could easily configure, either because you just know you want to always get all the rows for one particular query or all the queries. And what you get for this is that the row set is detached from the connection. So this could have some utility on its own. If you want to have your application start up, do a query, get a row set. That row set can effectively have its own lifespan and does not need to be attached to a connection or any other database resources. So it has some utility. The other thing that can be done is the row set can be upgraded from an input range to a random access range. So that has some utility as well. There potentially is no additional copying here except for drivers which do not provide buffers, in which case then you might have to copy it. But generally I see this kind of a feature as a caching enabler. So if, for instance, you wanted to hold local row sets that you would keep just in your application and avoid querying the database at all, this is something that would help. Okay, so I want to cover input binding a little bit. We saw an example earlier. This is just a repeat of that in the sense that input binding is something that you would use when you want to repeat the same query over and over. Question?
Yes, can you use this asynchronously?
Sorry, could you repeat the question?
Can you use this interface asynchronously, or is it blocking?
We're going to get to asynchronous.
Okay, thank you.
So input query is the analogous capability to output binding in the sense that instead of doing select queries, you're doing inserts in the database. Many drivers provide the ability to do input binding. And this, again, is not something exposed in the interface. The interface provides an abstraction on top of that to make it easy. So again, here, we're just providing the ability to execute the query once and then repeatedly issue parameters on it without resending the query. Now, just like with output array binding, you can do input array binding in many cases. And so what you're doing then is the interface is holding in buffers for, in this case, 1,000 rows before it actually sends them to the server. This is actually potentially more impactful than the output binding because it's combining the fact that you're not preparing the query each time you run it along with array binding. And unfortunately, I don't have numbers for this, but I do know from experience that this can be dramatic. The only downside of doing this is that you are deferring the appearance of those records in the database until the buffer flushes. So if it's a case where you don't care about those records appearing to other connections, you just want to blast records into the database as quickly as possible, this is a really good thing to do. Type conversion I mentioned previously. Now there's a two-layer aspect to this in the sense that the driver layer, you have to tell it what the types are you're binding to, and that's something handled internally by the driver. And then the front end of this has to say, well, what is the user asking for? So you have on one case two things happening where the driver has to decide how to bind it, and usually picks a binding that's matching the database type. So and it's going to go, every database type maps to some D type that's going to be the default for how it's stored. And then the application may or may not ask for that same type. So there's a little bit of a no-win situation here in the sense that the driver has to guess the default is to always store native types. However, if the user is intending to access everything by string, then there will be a conversion cost there. However, you could have a setting that says, don't just do the conversion once, and the second layer conversion is not going to have to convert again, because if you know ahead of time what is being accessed, you can optimize for that. So policies represent simply a parameter that goes into this design. In the sense, one of the things that was necessary to have this be a candidate for Phobos, so that it all had to be templated. And there's a lot of other reasons why you can take advantage of the fact that this is a template design. But one particular thing that you can do is you can pass in a policy. And a policy is just something that holds things you'd like to customize about your particular database. So there is a notion of a default policy that is just the defaults for whatever you get. But if you have a particular behavior, a particular thing that you want customized at compile time, you can use this policy and instantiate the database class to get that effect. And so some examples of that, you may want to have control over the allocators. You may want to have a pluggable connection pool. You may want to say, you know what, I know my application is going to always have certain types of conversion patterns. For instance, you always know that if you're bound to an int, you're always going to get an int. You're not going to ask for it as a string. You could potentially tell the policy that I just want to assert on release builds on type conversion, so that in a debug build, you would get an exception, but in a release build, it would just assume that you knew what you were doing if you really want to perform. So of course, that wouldn't make a good default, but this is just some examples of what you could do with this customization. You could go so far as to say, you know what, I never actually use the reference counting nature of these objects. I may say in my particular case, they are always scoped. You could actually disable reference counting entirely if you wanted to. I don't know if that is going to be a good idea or not, but I think it's possible. You can also do things like omit handle accessors. So if you want to say, you know what, I want to make sure in my build that nobody is accessing these handles, you can do that. In fact, the default on that should probably not to be able to access them. So now I want to just go one layer above my driver layer and just talk about a particular utility of this library that you could do. So in this example here is about joining. So this is something that you would do on top of the interface, and it's a particular use case I've encountered in projects. And I'm going to show that there's three tables involved here. There's an inventory table, and it has a relationship to an orders and parts table. And both of those relationships are one-to-end, meaning that for each inventory record, there's multiple order records. For each inventory record, there's multiple parts orders. Now, the problem here is that it's actually kind of difficult in a SQL query to return this result. If you just had a pair of tables, of course, you can just join those two and you'll simply get repeated rows for the inventory and unique rows for the orders, for example. But if you want to get multiple hierarchies out of a query, it's just awkward. You end up with a table that has just a lot of repeated information. It's difficult for the application to untangle that. This really represents a hierarchy result. It's not a great fit for tables. However, this is something I've used to get around that. And it makes use of a join operation. So let me just walk you through this a little bit. In this case, I'm going to get three separate connections to the database, one for each table. And so I'm using create connection because I'm going to need those three connections. And what I'm going to do is I've got a base table, which is the inventory, and two slave tables, if you will, for orders and parts. And the dependency here on orders and parts is that they are sorted. So I'm specifying that they're ordered by the primary key of inventory, even though the second one is actually missing an ordered by clause. It should have one. And what this join does is exactly what the database does. In fact, I call this a client-side join. And what happens here is you construct this joined rows, which is itself a row set. And what it has a row set interface, just like an ordinary one would. And what it's going to do is perform the join. And what it's going to do is, as you're looping through these joined rows, it's going to take the row sets that you passed it and advance them in the correct way. So in other words, what it does is it steps through inventory. For each record of inventory, it's going to essentially seek to the record in each of the child tables. And it has the correct logic so that as you're iterating through inventory, as long as there are rows in each of the child tables that need to be advanced, it advances those. And it's only when it reaches the end of that particular group of joined records does it then advance the base table. And it's all done lazily. And so the benefit here is that you can retrieve the information very naturally in ways that you wouldn't be able to do with a simple query. So, and this can be, the nice thing about this is I think this can be built on top of a join that really has nothing to do with databases. It's a fairly generic operation, may only need slight modification for, I call this natural join because that's a simple case where it's going to match up based on the names of the columns, so you don't have to specify those. So, and this actually can scale quite well. So these ordered by things can be really expensive on large tables. But if you have a database that supports clustered indexes, then it's maintaining those tables in ordered form with trade-offs. But essentially, that can be something that has millions of records. Question?
Right, so you say this is a client-side join, obviously. but maybe it would be wise, you know, to choose a type of join. Maybe for my particular case, hash join would be much performant than this, let's say.
It could be, although this doesn't require any auxiliary structures. If the data is ordered, the cost of this join is extremely small. So I think there are a lot of potential use cases here. This is just one example. I just pointed out because I think this is something that is not something I see commonly done by application developers who are faced with the same problem. And the thing that's really remarkable here is this is really, the implementation of this join is very easy to do in the presence of ranges. So it's a nice fit. Okay, so I have this
Erik?
here. Question?
Here, in the back. So this is rare. I gotta say, it's like traditionally, people are going to do a join in the SQL and transmit as little data as possible. Right now, you're going to be streaming data from 3 large queries, and you're going to join on the client side. I assume there are use cases for that, but they're gonna be rare. However, I do commend the idea, and I think there's a lot of flexibility there. And natural join is a natural candidate in, we have the sorted range facility. And sorted range takes an input range and assumes it's sorted, and it already has join as a member function, I think. And you could add more of these joins in or out or whatnot. So I think it's an interesting idea, but it comes with this big caveat that, well, it's going to be rare that people are going to want to do that. What are your thoughts about the main use cases?
Well, to me, it's maybe not the performance of this, it's the fact that I find it quite common that you do need to get hierarchies out of the database, and I think it's awkward to do so. I mean, I think many applications will effectively do the join by pulling in separate queries and then doing it in application logic. So, maybe the equivalent is being constructed very commonly, and there isn't much thought about just how to naturally get the data in something that might be a better hierarchy. In fact, I think actually you could map this onto a neutral interface designed to navigate hierarchies. So maybe the same interface that you would use to navigate an XML or JSON document could actually map to this, and it would be just an interesting way to get data out of relational database.
Actually, there is one situation which clearly it's a win to do it on the client, which will be a full cross product. I forgot how that is in database terminology. What's the name of it? Full cross product. Full outer join, I suppose, right? Is that the one? I think so. So you do a full outer join, and instead of doing a full outer join in the engine and then streaming the whole goddamn data to you, you just stream the tables, and you do it in memory on the client, which is pretty cool, and probably take only the first few rows. So I think there are good scenarios, and I do think natural join and other joins are great candidates for sorted range in general, not only for databases. It's a great idea. Thank you.
The other aspect I should point out here also is that if you have an application that deals with federated data sources, you may have a need to join. So this example has a connection open to the same database, 3 different connections, but I can imagine, especially with the trend toward things like microservices where you're splitting up services, you may want to join information from disparate sources in using this type of approach. So I have this here because I want viewers to have an understanding of this interface and understand how it applies to what they may be doing, and they may not be familiar with the details of the D language, but I want to make sure that people understand from this point forward, there's implementation details. These are not details that an application user would have to do, but I think there's some interesting things in here. A couple things about the design. Again, having chosen to create a front end for this really helped accelerate the project. I was surprised at how well it worked out. And again, it's using ref counted. The ref counted payload is the natural division line between the front end and the back end. So you can imagine that you've got these 7 types. They're all holding ref counted, and that ref counted payload corresponds to the same type in the driver side. Okay, so there's this duality between the front and the end. There's a database type on the front end. There's a corresponding database type on the driver layer. And what it does is it frees up the driver implementer from having to handle a lot of details in the front end. They don't have to worry about reference counting. They don't have to worry about connection pulling. There's all this state management that occurs in the front end. There's a bunch of redundancy in the functions, as you saw before, so that you can query on different objects. None of that is the responsibility of the driver implementer. So what I'm doing is I'm trying to push out all the complexity of developing a driver and have the driver focus just on the details that it needs to. And I think this is important because if you look at other driver implementations, they're just horribly complex. And in order for this to be scalable and maintainable, you really want to have a clean driver interface so it's easy to add new drivers and to maintain existing ones. So just a little brief walkthrough of the driver design here. The steps you need to implement a driver are the following. So you first define the database type for that particular driver, and this is in an isolated package for, in this case, MySQL. You define this alias that just says, I want to expose a database type with its policy as an alias of basic database. So the front end has types all prefixed with basic, and they're instantiated with the driver and the policy. So you paste that line in, now you have your database type covered. The second function is a factory function that you need to get the database, and it returns a default policy. Although there could be a template version for getting your own, or you can just directly instantiate database with the policy that you want. And then that's about it. Now, all the other types that you might need to work with don't need to be implemented here. They're all discoverable once you have the database type. So you don't need to say, okay, alias, connection statement. That's the only thing you have to do as far as exposing the types. The second part of this is what you actually put in this file as far as the driver. And the way that this worked out is you say struct driver as a template of policy. And within here, you define these simple structs for database connection statement result. And what the front end is going to do is it's going to manage the construction and the calling of these objects. It's going to make sure that when you get a connection, it's getting a pointer to the database object, so whatever you did with database will be handed back to you when you do the connection. So it's
Erik,
a nice,
you have about
structure.
5 minutes left.
How much?
About 5 minutes.
Well, okay, so just going quickly through here, this is a little bit expanded form of the driver interface that I mentioned where it's passing the pointers in. Again, you do not have to worry about the lifetime of these objects. It's all managed. This is familiar to other talks in the sense that I'm using, this is for the poly driver. So the poly has to implement polymorphism for each of the registered drivers, and that's done in a similar way with simulated virtual tables and void pointers. One interesting aspect of the poly driver, I hope I have time to cover this. Everything was going along well until I got to the VARIADIC argument call, okay? And I thought, okay, well, how am I going to deal with that? So I need to transport arguments from templates in one query to another at runtime. So I have VARIADIC call, I'm getting arguments. I need to package those up in some way and transport them to another VARIADIC call. And the problem is those template definitions behind those two things occur at different times, so I can't directly connect them. And I also wanted to avoid requiring the drivers to handle variant arguments. I want to keep all the complexity away from the drivers. So there's two issues. One is the transport, one is keeping variants away from the drivers. So I have this nice mapping here of what's occurring here. I'm taking the front end's VARIADIC arguments and packaging them in a standard array. I channel them through the void pointer calls, And there's two key calls, there's two key pieces of code here which I had to implement to make this work. One is call VARIADIC, and one is unpack variants. So those each solve the two problems there. So this is where I'm packing into the variant array, as I described before. Okay, this is an unnatural piece of code in the sense that you don't usually want to do this. You don't usually have a need to do this. It's easy to go from compile time to runtime, but not the opposite. And I think this can be done more cleanly, but just for the purpose of getting an experiment, I went ahead and just cased out. So depending on the runtime case, it's going to actually construct the right call. This is an interesting piece of code, and this is the first time I've really used VARIADIC templates to any complexity. And what it's doing is going from left to right, and it's taking each variant argument one at a time and replacing it as its own type. So you can imagine it's going through from left to right. If it sees a variant int, it's going to take it to be an int. So those two problems are handled. Now, does anybody see a problem with this approach? Nobody? Okay. So this didn't work out quite as expected. And the reason is because this generation of code is you're basically taking, say, 10 types put in 5 slots. So that's a permutation 10, 5. You're asking the compiler to generate over 30,000 functions, okay? And it's kind of funny because, you know, I'm working with it, and I add an additional line in the case statement, and suddenly the program comes unresponsive. I thought maybe the compiler was punishing me because of the way I was using the switch, and I just ignored it. But then it occurred to me when I realized later that, in fact, I am generating a large number. And this permutation goes up very quickly. And the compiler actually works. It actually, I think, in this case, it took 30 seconds. If you go one step beyond, it took just under 2 minutes. Now I can imagine that this is something that maybe people want to do in the future. I think in this case, it's just overkill. I think clearly the drivers really should just, I mean, it's forced to the drivers are forced to take both the compile time version and just an array at runtime. It's not a big deal for the driver, but it's just, it's something that is workable. But this idea of generating functions can definitely be taken to a whole new level. I think if all I did, though, was if I take away one of those things, like I don't convert the variants, then it's workable. Then you have a very small number of functions. But this Cartesian product of things results in this explosion of functions that doesn't work very well right now. So I think a very important question is about asynchronous support for this driver. And when we talk about asynchronous, I think that there is certainly things that you would want to address there, but probably the more immediate need is how does this fit into a fiber approach such that Vibe uses? There's actually 3 ways to do that. And I think the first 2 are problematic in the sense you don't usually have the source of the driver so that you can replace the TCP calls, and you don't always have the wire protocol. You actually don't have often asynchronous or non-blocking drivers to work with, and there are a few. This is an example of how you would adapt a driver that does have non-blocking calls to the Vibe event system. And I think this can be generalized, and I know that what's in Vibe as far as the event system is going to get pulled out. So in theory, the green calls are the Vibe calls, the red calls are what the driver's non-blocking calls would be. And the main thing is for the drivers that do support non-blocking, you should be able to expose a synchronous interface, meaning all the things I just reviewed in a fiber-based approach. So that's the good news, as opposed to maybe an asynchronous approach would involve callbacks. Vibe already has support for, I think, MySQL through the native driver and Postgres. There is limited number of drivers that have non-blocking calls, but this is an interesting one, and this is the one I want to look at next. Web scale SQL is a MySQL compatible client that implements non-blocking calls. It actually works against existing MySQL databases, and so I want to target that.
I hate to interrupt you, Erik, but you got to bring the talk to a close so we
Okay.
can fit the rest of the
I'm
agenda.
actually just about done.
Okay.
I've just got my current supported databases. I've got the ones I'm going to do up next. The one on the top is a work in progress as far as features. There's upcoming work to do, and this is an incomplete list. There's a getting started, just for anybody who wants to try this out. And questions.
We can take one single question.
How does this gel or not with what Martin presented earlier on today?
I think it's entirely complementary. I mean, in the sense that I think this would make a good foundation for an ORM layer. So I think there's no overlap. I think they're entirely complementary.
Thanks.
So thank you, Erik.